Okay, now start. Now start.
Okay, so the fundamentals of mathematics are built on the concept of axioms, um, which means that like math and stuff is defined, and in order to you know operate in math, you need to define everything, right? So in the case of like a set of natural numbers, for example, what do we know about natural numbers? Well, let's go with the concept of integers for a second. So we're going to start with integers, and we're going to say, what's the origin point of numbers? Is it 1 or is it 0? In this case, we're going to go with the starting point as being 0. 1, 2, 3, 7,000, whatever. But what's the definition of a 1? How do you define a 1? Well, in this case, we define it as the successor of 0. 1 is defined by the number that came before it, not its own. Where 0 is a number. Okay, in this particular set, 0 is a number. So, it's defined by that. The next one, for example, 2 is defined as the successor of 0. I know this is 1, so the successor of 1 is 2, correct? Let me go a little further. I'm going to stop writing with the S notation. I'm just going to put the number in there. So the successor of 17 is 18, right? Well, now we have one here that's a bit of a conundrum here. Because the successor of 18 in this one, the operation here, 9 plus 10 is equivalent to the successor of 18. And in this case, we're saying it equals 21. Now, the most important thing to note is that this marker sucks. And there's probably a better one. There is. So the successor of 18 in this particular equation is defined as 21. And so if we define it as 21, and we write that as a part of the equation, this becomes true. Why is that? Because the very concept of what number comes after the other is something that is defined. And if I say, well, I'm changing the definition in this case, it is. So when that kid was talking about, when his brother was asking, what's 9 plus 10? He says 21. He wasn't wrong. He was just thinking about mathematics on like a fundamental level, and he changed it. And rather than realizing, oh wait, I need to discuss in normal mathematical terms of like a normal natural number set, he was still thinking in his own custom one, which defined the successor of 18 as 21. Right? So 9 plus 10 does equal 21. Are we in agreement, sir? Are we sure? Okay.
Yes.
Is that enough evidence you need? Do you
Yeah.
need anything else? Any questions?
I need no more evidence.
No more evidence.
I'm satisfied.
Good. Anything else?
Hmm?
Would you like another math lesson?
Yes, please. This video is only 4 minutes long so far.
Okay.
I need to get I need to get the runtime up so I can get more views. I can get more monetization. I want monetization. Nut.
Okay. So, say we have.
Teach about algebraic topology.
No, I'm good on that one. So let's say we have a graph.
All right, we have a
You got
graph.
an hour?
I got an hour.
So we have a graph, x, y, typical stuff, right? If I want the equation y equals x squared, what is that?
Y equals what?
Y equals x squared. What does it equal?
Well, there's. Give me numbers.
Yeah, we're graphing it. just to give me a point. Y equals x squared, so let's go with x equals 0. What does y equal?
0.
Yes. So 1 point is there. X equals 1 squared.
1.
And so y equals 1. X equals 2. 2 squared.
4.
We got 2, and then it goes up 4. I'm going to do the same thing over here. It goes up. What we have here is a parabola. So let me get a more clear drawing on here. So we have a parabola.
You're playing Angry Birds?
We have a line in the middle.
Oh shit, he's playing Happy Wheels.
Is happy. So when we have our line here, let's say we want to multiply two numbers together, right?
Mm-hmm.
So when we have 2 times 2, what does it equal?
4.
4. Well, in this particular case, we're going to go 2 digits over, up, 2 digits over, up, and we're going to go up until we hit the parabola, and then we're going to draw a line between these two. There we go. Draw a line between these two. And then we have this point here. Okay? This point is equal to 4. So this point over here is 2 over. This point over here is 2 over. I mean, the distance of the line from the center is, you have 4. That's y equals 4. So in this case, you multiply the numbers. Well, you can also, change that. So I mean, I can make this a 5 or something. I can go up, and then I can redraw the line. I can put it here. Instead. So I have a 2 and I have a 5. So therefore, the value of this point is, what is it?
3.
No, it's 10. See, whatever I change this to should be 100 over here. Whatever I change this to, the point where it meets on the parabola, drawn a line down to here. The point where it meets here will be the equivalent value if you multiply the two distances away from the, away from x. So this is distance from x in the negative direction. This is distance from x in the positive direction. So
500.
this point can be defined as 500. Yeah. And this goes on forever and ever and ever, and it will always work on the graph of y equals x squared.
Mm-hmm.
This is a useless trick, but it's nice to know. So if you ever have something special about parabolas, you're trying to figure out how it works out, and how, why does, if I move 2 over, it's the same number, so I go up, well normally it'll just be, I can put it in here, the y is equivalent to the y across. When I do this, it's not exactly the case. It's not exactly half either. If you go 100 squared is what?
1,000.
Yeah.
Wait, no, or is it 10,000?
1,000 times 1,000, and 100 times 100 is 1,000.
100 times 10 is 1,000.
100 times 100
is 10,000.
10,000.
It's 10,000.
The value up here is 10,000, and the value over here, 5 squared is 25, so it's 25. But the point in the middle here is only 500, because of how steep the line is. And this line is the y-axis right here. So the point where it intersects on the y-axis is the equivalent value of if you were to multiply the x values together. Pretty epic, right?
Yeah.
It's a fun trick. Okay, what's next?
Conversion between Celsius and Fahrenheit and vice versa.
Okay. See, to have, take a temperature in C, add, multiply it by 9/5 and add rate 2. I'm pretty good, right?
Is that it for the math lesson today?
Anything else?
Uh.
Anything you want now?
Give me the entire. Make me an expert on algebraic topology.
The first lesson would take 5 hours.
Then I got 5 hours. Let's do this.
You do not, though. You have work to do.
All right.
See, I sent Bennett the full course. Would you like it?
Yes, please. Is that the end of the math lesson?
Yes.
Okay, then I'll cut the stream off.
Some guy made the